So this is the discussion of control variables for the data analysis controlled assessment. We're going to look at an example that we've used already for looking at dependent and independent variables, which is the example of a student testing to see how changing the angle of a slope affects the time it takes for a car to roll down the slope. So when you're doing this, you've clearly got the independent and dependent variable, which we've identified in previous videos. So the independent variable is angle of the slope, that's what you're going to change. And the dependent variable is the time it takes for a car to roll down the slope. That's the thing you're going to measure changing as a consequence of changing the angle. The control variables then are variables other than the independent and dependent variable, which are kept the same during the experiment, and that helps you to make what we call a valid conclusion. In Key Stage 3 language, we would say that you were doing a fair test if you had the control variables properly controlled. So the question is then, you'd like to keep everything else the same, because what we really want in an experiment is only the independent variable affecting the dependent variable. Okay, but it's important to identify which variables that you think might be really important, and then talk about how you're going to control them. So for every control variable, you should say what the variable is, explain how you will control it, so what you will actually do to keep it the same. Sometimes that's very straightforward and sometimes it's not. And then the trickier part is to explain why it's important. And the reason is that it could affect, it could affect the dependent variable. So in this case, it could affect the time it takes for a car to roll down the slope. And you need to have some sort of scientific reason for why it might affect it. That's the best discussion of control variables you could do. So let's take this example then and look at one control variable. If you're rolling a car down the slope, then the starting point on the slope, or the distance travelled on the slope, which are equivalent, is really important. If you change that, it's going to affect your results. So here's our statement then. So I've identified the variable. I've explained how I will control it. So I control this by marking a release point on the slope, lining up the front wheels of the car with this point every time it's released. So notice it's very specific. I've not just said something like do the experiment the same way every time. I've talked about an exact detail of the procedure and how it's going to control that variable, the distance travelled on the slope. Okay, and then the last bullet point here, it's important to control this variable, as if the distance travelled on the slope is longer, it will take longer for the car to roll down the slope. So I've linked the control variable with its likely effect on the dependent variable here. Right, so that's explaining why it's important to control it. Okay, so let's see, for the same experiment then, can you come up with some other control variables and explain how you're going to control them and why it's important to do so? I've got two examples I'll go through with you after you've paused this and done that. There may be others that you've come up with, that's fine. It's just practicing the procedure is the important thing. So pause the video now and try and do that, please. Okay, so let's look at some of the ones that I thought would be a good idea, and you may have others, that's fine. So, I said the material of the slope, or possibly the nature of the slope surface. Okay, if we change that, it's going to have an effect. So I'll control this by using the same slope for every experiment, that's very easy to do. And also a little bit more detail, rather than just saying same slope, is to make sure the slope surface is uniform, so the same all the way down, and the same all the way across, because if you didn't roll the car down in exactly the same place every time, or even if you did, it might roll a slightly different way. If you have some rough or some smooth patches, it could affect the time it took to get down the slope. So a rougher or smooth slope will affect the amount of friction between the car wheels and the slope. This could affect the time it takes for the car to roll down the slope. So there's our explanation of why we'd want to control that. Second example that you could have used. The force applied to the car on release, or the technique for releasing the car. Ideally, we don't want to apply any force, but if you release a car on a slope, you can do it lots of different ways. So this is something else we need to control. All right. So make sure the same person does the release if you're working in a group, and they use the same method, and be explicit about the method. Right. So put your thumb and index finger on either side of the car and release them both together. Okay, if you do it the same way every time, you are less likely to change the force that you're applying to it. You should have zero force applied to it, okay? So variation in the release of the car can apply a small force as it's released, making it start off at different speeds each time. The speed variation will affect the time it takes for the car to roll down the slope. Okay, what we're ideally looking for is it to start, as we start the timer, start it at 0 speed at the top of the slope as we release it. If you do give it a little shove, that's going to introduce some variation and it could affect the results. So you may have some other ones. This doesn't necessarily mean that they're wrong if I haven't gone through them here, but they should look in a similar way to the two examples we've just done. Name the variable, explain how you're going to control it, explain why it's important to do so. And that's our discussion of control variables.